Welcome to the Skeptical Chemist YouTube channel, your online lecture hall where chemistry is made easy. Our subject of interest today is isotopes. We will cover the fundamental concepts behind isotopes and explain the notation used to represent them. Then, to help you better understand isotopes, we will work through examples and highlight the types of questions you may see on your exam. Let us begin. It is helpful to recall that atoms are composed of subatomic particles, and that all things are composed of atoms. These subatomic particles are protons, neutrons, and electrons. Remember that protons and neutrons have similar, but not identical masses, and that they are heavier than electrons. Together they are found at the center of an atom. Protons and electrons have an equal but opposite electric charge. Protons carry a charge of +1, while electrons carry a charge of -1. This keeps an atom electrically neutral. If all things are made of atoms, and therefore protons, neutrons, and electrons, then what distinguishes one atom from another is the number of subatomic particles that are present. This brings us to the topic of isotopes. An isotope is an atom of a given element that has the same number of protons but a different number of neutrons. Another way of saying this is that isotopes are different forms of the same element where the number of protons remain the same but the number of neutrons vary. While the number of neutrons in an element may vary, the number of protons will always remain the same for a given element. For this reason, the number of protons becomes what identifies an element. Every element has isotopes. Some are stable and some are unstable. An isotope is said to be stable when it does not undergo radioactive decay. Some elements have many stable isotopes, while others, like fluorine, have only one stable isotope but 17 unstable isotopes. Both stable and unstable isotopes occur naturally. The primary or the most abundant isotope of an element are sometimes referred to as the standard isotope. For example, when you think of carbon, you usually think of carbon-12, even though other carbon isotopes exist. Because protons and electrons have equal but opposite charges in a neutral atom, the number of protons will be equal to the number of electrons. And because of this, isotopes of a given element are chemically similar. Remember, it's the electrons that determine how an element behaves. The word isotope comes from the Greek iso, meaning same, and topos, meaning place. Here, the place refers to the place on the periodic table, and the periodic table was arranged according to chemical behavior. Chemistry makes use of symbolic notation to represent chemical concepts. In order to understand chemistry, you need to be able to recognize and use chemical notation. The number of protons in an atom is called the atomic number and is represented by the symbol Z. Each element has a unique atomic number. The mass number is represented by the symbol A and indicates the total number of neutrons and protons in an atom. Finally, each element is represented by a chemical symbol X. This is a 1 or 2 letter code that is specific to each element. For example, carbon is represented by C and oxygen represented by O. These chemical symbols are used throughout the periodic table. Now let us see how the symbols are used in practice. A common notation style is the AZX notation. This is also called nuclear notation. The mass number A is written as a superscript to the left of the chemical symbol, and the atomic number Z is written as a subscript to the left of the chemical symbol. Let us use carbon as an example. The chemical symbol for carbon is C, and the standard form of carbon has 6 protons and 6 neutrons. The number of protons is represented by Z, and the mass number indicates the total number of protons and neutrons. In this case, that is 12. Next, we have the carbon-13 isotope. The number of protons remains the same, but 1 more neutron is present, making the mass number increase by 1. Carbon-14 has 2 more neutrons when compared to the standard isotope, and this is also reflected in the mass number. Both X and Z are symbols that represent one unique element. For this reason, including both X and Z in the notation is redundant, and it is common to drop the Z from the notation. Be aware of this. Another common notation style is just the chemical symbol and the mass number separated by a dash. This style is used to explicitly indicate the isotope. The chemical symbol can be used, or the element's full name can be used. In summary, these are the three major notation styles for isotopes. Now let us work through some examples. Say you are given the following question. Using AZX notation, write the correct chemical symbol for the isotope of oxygen that has 10 neutrons. The best place to start is with the information that you've been given, and then identify what you need to answer the question. Here, we are working with an oxygen atom that has 10 neutrons, and we want to represent it in nuclear notation. Therefore, we need the numerical values of A and Z and the chemical symbol for oxygen. Oxygen is represented by O. Some of the chemical symbols are intuitive, like O for oxygen, and others are not as intuitive, like Fe that represents iron. With practice, you will memorize the symbols for the common elements by default. Using the periodic table, we can find the atomic number of oxygen. Note that the atomic number is listed above the chemical symbol on the periodic table. For oxygen, Z is 8. We've been given the number of neutrons, 10, and we know that the mass number is the total number of neutrons and protons. The atomic number Z equals the number of protons, so 8 plus 10 is equal to our mass number. Now we have the information needed to represent oxygen 10 in AZX notation. Let us do another example. If uranium-235 has 143 neutrons, how many neutrons does uranium-238 have? Let us approach this problem without using the periodic table to see how the subatomic particles of a specific isotope are related. Uranium-235 has a mass number of 235. Recognize that this is X-A notation. We know that the mass number is equal to the number of protons plus the number of neutrons, and we are given the mass number and the number of neutrons for uranium-235. We can solve for the number of protons, knowing that the number of protons will be the same for all uranium atoms. After we balance the equation, we find that uranium-235 has 92 protons. Uranium-238 has a mass number of 238, and now we know that uranium has 92 protons. Therefore, we can now solve for the number of neutrons by removing 92 from both sides of the equation. So uranium-238 has a total of 146 neutrons. If an isotope of barium has a mass number of 144, write the correct AZX notation for this isotope. Let's start with what we know. We are working with the element barium, and we need to represent barium-144 in nuclear notation. Therefore, we need to find the values for Z and X. If you are familiar with the periodic table, you will know that barium is represented by the letters Ba. Once we have the correct chemical symbol, then we can use the periodic table to identify the atomic number. Here, the atomic number is 56, and now we have all the information we need to represent barium-144 in AZX notation. An element has an atomic number of 26 and a mass number of 56. Express this element using both AZX notation and X-A notation. Here, we are given the atomic number and the mass number. All we need to do is find what element the atomic number corresponds to on the periodic table. In this case, the atomic number 26 represents iron. And now we have all the information we need to express this element using both notation styles. You should be able to represent isotopes using the standard isotope notation formats and derive relevant information from isotope notation to answer questions. This includes being able to convert between different notation formats, and being able to calculate the number of subatomic particles in any given isotope. A notebook with the style of Cornell notes used in this presentation is available on Amazon. Search Cornell and Recall Notebook or see the link below. And if you would like to see more content like this, like and subscribe. Thank you and happy study.